Welcome to Honors Algebra 2 in our Flip Learning videos. A couple of reminders before we get started. You can stop and re-watch your videos at any time. I highly advise you to watch them multiple times, especially before a test. You can always go back and re-watch the videos to go over the concepts. Also, if you're struggling with the concept, you can always come back to the video and re-watch it as well. Also, if you lost your set of notes and you want to reprint your notes, there's a PDF available to the right of this video where you can download and print your notes if you need them. These are the notes for lesson 1.1, real numbers and number operations. There are two different sets of numbers, the real number system and the imaginary number system. We're going to talk about the imaginary number system later on in the year, and right now we're going to focus on the real number system. This should be something that is familiar to you. Real numbers are made up of rational numbers and irrational numbers. And as the definitions say below, rational numbers are numbers that can be written as a fraction or a decimal that terminates or repeats, so it ends or it just keeps repeating. Irrational numbers are real numbers that are not rational, so the decimals do not repeat or they do not terminate. Now, rational numbers can also be broken into smaller categories. The first is integers, and that's positive or negative whole numbers, and it includes 0. So the two definitions that you don't have, a whole number does not include negative numbers. So it's numbers like 0, 1, 2, 3, and so on and so forth. Now, natural numbers are just the whole numbers, but they don't include 0. So again, we can classify each number and determine which category it falls into. So for example 1, I want you to look at each of these numbers and I want you to write them in the boxes above where you think it belongs. So for example, 293, notice that it's not a negative number, so therefore it is a whole number. So in the box above, on whole numbers, you'll write the number 293. I want you to pause the video, take those numbers, put them in the appropriate boxes, and then replay the video and we'll go through where they go. All right, let's check to make sure that you have them in the correct spots. Negative 47, notice it's a negative number and it's a whole number, so it's going to be in the integers. So negative 47 is an integer. 5/9 is a fraction, so therefore it's a rational number. So 5/9 goes in rational numbers. The next one, 184 thousandths. Notice that the decimal terminates or it ends. It doesn't keep going, so therefore that is a rational number as well. The next one, 6/3. 6 divided by 3 is 2. So if we simplify this, 2 is actually a whole number. The next one is the square root of 7. Now, if you were to type that into your calculator, you'll notice that the decimal is going to go on and on and on forever. 2.645, and it keeps going. It never ends. So therefore, the square root of 7 is an irrational number. Negative 42 hundredths. Again, the decimal ends. So therefore, this is a rational number. The next one is pi. Pi is 3.14 and it keeps going on and on and on forever. It does not repeat, so therefore pi is an irrational number as well. The next one is negative 7/1. Again, if you simplify that, that is negative 7, and negative 7 is an integer. The next one is negative square root of 9. The square root of 9 is 3, so this would be negative 3. So therefore, that would be an integer. And last one, 4 2/3. Again, it's written as a fraction, so therefore that would be a rational number. And you'll notice that some numbers, such as the whole numbers, are also integers and are also rational numbers. Now, in between any two real numbers, there are an infinite number of numbers. So there are infinitely many numbers. So is 0 positive, negative, or neither? 0 is a special number. It is actually neither positive or negative. And if we're looking at odd and even numbers, 0 is neither as well. So 0 is a special number that is actually very helpful in a lot of cases, and we're going to talk about that more as we get into different Algebra 2 concepts. Next thing I want to look at is the number line. There are some different terminology, there are different terms that we need for a number line. The first is the origin, and that is the center point or 0 on a number line. And when we start graphing, we're going to talk about the origin of a coordinate plane as well. But again, on a number line, the origin is 0. The next one is a graph, and that's the point on the number line that corresponds to a real number. And we're going to graph some points in just a second, and we'll label that. And lastly is the coordinate, and that's the number that corresponds to a point on the graph. So if we have a point, it's the number that goes along with that. We call that a coordinate. So the first number that we want to put on the number line is -4/3. Now if we're looking at a number line, the easiest way to put numbers on a number line is to make them all the same or the same form. The easiest way to do that is to change them all to decimals, and you can do that very easily with a calculator or by dividing it out, in this case with the fraction. So if we have -4/3 as a decimal, that is -1.3 repeating. So if we go to our number line, we're going to go to -1, and it's 0.3, so we're going to go a little bit further to the left, but not quite to halfway, and we're going to put a point there. So the point is our graph. And again, we need to label it or label the coordinate, and this is -1.3. So the label that we give to the point is what we call our coordinate. Now we can do the same with the other two numbers. The square root of 2, again, if you just type that into your calculator, it is 1.4142. And make sure you type these in and make sure that you know how to do that. So 1.412, we're going to go over to +1, and we're not quite to the halfway mark because that would be 0.5. So we're going to put our graph a little bit before the halfway mark. And again, we need to label it. And we're going to label it with our original number, which we should have done in our previous example. So let's fix that one. This should be -4/3. And lastly, we have 2.7. So we're going to go over to 2. 0.7 is more than a half. So we're going to go a little bit over a half, almost to 3. Put our graph there and label it as 2.7. Again, these should be skills that you've done before. So then what statements can we create using the less than and greater than sign using the numbers that we just used? So remember, this is your less than sign, and this is greater than. And if you remember from elementary school, think of it as eating the bigger number. So we could say that 2.7 is greater than -4/3. And then I want you to write a couple more examples using your less than and greater than signs. In the last section, we are looking at properties of addition and multiplication. So in these examples, we are going to look at the letters A, B, and C, and they are all real numbers. So we just talked about what real numbers look like. So again, A, B, and C are all real, or any real number. So the commutative property, again, we're looking at addition and multiplication. The commutative property just means that we can change the order. If we change the order in multiplication or addition, we know that it does not change our solution. So for addition, for example, we could have A plus B, and we know that that is the same as B plus A. If we add either of those, we know that we will get the same sum. For multiplication, it's the same way. If we multiply A times B, we know that that's the same as B times A. So again, the order does not matter in addition and multiplication, and that is the commutative property. The next property is the associative property, and this just tells us that the groupings can change. So for addition, if we are adding A plus B, we group those together in parentheses, and then we add C, that's the same as saying A plus B plus C. So again, the groupings can change. It does not change our sum. Same is true with multiplication. We can multiply A times B first, and then multiply C times that. And that's the same as saying A times B times C. So again, the groupings don't matter for multiplication and addition. And again, that is the associative property. The next one is the identity property. So basically we are looking at a number that we can multiply or add to a number to get that same number. So the identity property, we are going to add 0. If we add 0 to A, we know that we get A. And again, we can use the commutative property. We know that 0 plus A is also equal to A. For multiplication, in order to get the same number back when we multiply, we are going to multiply times 1. So A times 1 will give us A. Again, the commutative property works, so 1 times A is also A. For the inverse property, I want you to think of the opposite. So if we look down here, the definition of opposite is the additive inverse. So for example, if we have 3, the opposite of 3 would be negative 3, and also the inverse is true. So if we have negative 3, the opposite of that is positive 3. Another way to think of this is subtracting is the same as adding the opposite. So just another way that the opposite is used in math. So for the inverse property of addition, we are going to add opposites. So A plus a negative A, and we know that that equals 0. For the multiplication property, inverse property, we want to look at the reciprocal. And the reciprocal is the multiplicative inverse, so the inverse in multiplication. So for example, if we have 2/3, we know that the reciprocal of that, we just flip it, and that is 3/2. Again, a place where we see reciprocals when we are dividing fractions, that's the same as multiplying by the reciprocal. So if we are taking A, we're going to multiply that by the reciprocal of A, which is 1 over A. We know that that is going to be equal to 1. Now in this case, we know that A cannot equal 0 because we cannot have 0 in the denominator. And lastly, we have the distributive property. So if we have A and we're multiplying that times the sum of B plus C, we know that the distributive property tells us that we multiply everything outside the parentheses by everything inside the parentheses. So A times B would be AB, plus A times C, which is AC. I want you to look at these properties and think about whether they will work for subtraction and division. We've looked at how they work for multiplication and addition, but I want you to think about whether are there any numbers that will work so that these properties are true for subtraction and division as well. So example 3 says identify the properties shown. So in part A, notice that there are parentheses. So we're looking at groupings. So first we're grouping 3 and 9 together. In the second, or the other side of our equal sign, we are grouping 9 and 8. So that's a change in grouping. So that's going to be the associative property. Notice that it is addition, so it's the associative property of addition. And make sure you denote which operation you're using. In part B, the key here is that we are multiplying by 1, so that is going to be the identity property. Notice that we are multiplying, so it's the identity property of multiplication. An example form says to give an example of the commutative property. Now there's a lot of different examples that you can give. So make sure that you know how to come up with an example for this property. So the commutative property, if you remember, we are changing the order. So it does not matter what numbers you use. I'm going to use 2 and 3. So I know that 2 plus 3 is the same as 3 plus 2. I'm going to show you a multiplication example as well. It does not matter which operation you use if it does not specify. So for multiplication, we could do 2 times x, and we know that that's the same as x times 2. Again, I want you to look at these properties, and I want you to think about whether they work for all operations. So we know they work for addition and multiplication. Do they also work for subtraction and division?